Physicists say entropy always increases, disorder grows, the universe runs down. Time has a direction because of the second law of thermodynamics. From the Big Bang to the heat death, everything moves in one direction toward chaos, toward equilibrium, toward the end. But I'm going to tell you something that will disturb you. The arrow of time might be pointing the wrong way, and the evidence is right there in the cosmic microwave background. My name is Roger Penrose, and for decades I've been arguing that our most fundamental assumptions about time, entropy, and the beginning of the universe are backwards. Not wrong exactly, but backwards, and once you see it, you can never unsee it. Let me show you why the arrow of time is the greatest unsolved mystery in physics, and why the solution is more beautiful and more disturbing than anyone imagined. We begin with what everyone knows, the second law of thermodynamics. Entropy increases. This is the law that gives time its direction, its arrow. You can scramble an egg, but you cannot unscramble it. You can shatter a glass, but the shards will not spontaneously reassemble. Heat flows from hot to cold, never the reverse. These are not just observations. They are manifestations of a deeper statistical reality. Entropy is disorder. Roughly speaking, more precisely, it is the number of microscopic arrangements that look the same macroscopically. A scrambled egg has high entropy because there are countless ways to arrange its molecules that all look scrambled. An intact egg has low entropy because there are very few arrangements that maintain its organized structure. The second law says entropy tends to increase because high entropy states are vastly more probable than low entropy states. It is not impossible for a shattered glass to reassemble. It is merely stupendously unlikely. The atoms would have to move in precisely coordinated ways, and there are so many more ways for them to move randomly. Time's arrow emerges from this asymmetry. We remember the past and not the future because our brain's physical systems, obeying the second law, record information about lower entropy past states. We see cause followed by effect because effects are higher entropy outcomes of lower entropy causes. The future is open and uncertain because it contains more possible high entropy states. The past is fixed because there were fewer low entropy states leading to now. This is the standard story, and it is beautiful, profound, one of the deepest insights in all of physics. But there is a problem, a catastrophic problem that almost no one talks about. If entropy always increases, if the universe is constantly moving from order to disorder, from low entropy to high entropy, then where did the low entropy come from in the first place? The Big Bang. According to the standard cosmological model, the universe began in a state of extraordinarily low entropy. All the matter and energy in the observable universe compressed into an infinite decimal point, a singularity of unimaginable density and temperature, and then it exploded outward in a violent expansion we call the Big Bang. But here is what troubles me. What has troubled me for 50 years? Why was the Big Bang so low entropy? Think about it. If entropy is a measure of disorder, and if the Big Bang was this chaotic explosion of unimaginable violence, shouldn't it have been high entropy? Shouldn't have been the most disordered state possible, but it was not even close. The early universe was remarkably smooth, remarkably uniform. The cosmic microwave background, the radiation left over from the Big Bang, shows only tiny fluctuations in temperature, 1 part in 100,000. The universe at that moment was almost perfectly homogeneous, almost perfectly ordered in a thermodynamic sense. And that is deeply, profoundly weird. The probability of the universe starting in such a low entropy state is so vanishingly small that it should not have happened. The odds are something like 1 in 10 to the power of 10 to the power of 123. That is not a number you can visualize. It is not a number you can write down in any meaningful way. It is a number so large that if you tried to write it out, there would not be enough atoms in the universe to inscribe all the zeros. The universe should not have started this way, and yet it did. Why? This is called the problem of the low-entropy initial state, and it is one of the deepest mysteries in cosmology. Most physicists simply accept it as an initial condition, something we do not explain but merely assume. The universe started with low entropy, and that is that we move on. But I cannot move on because accepting an improbable initial condition is giving up. It is saying, this is just how it is without understanding why. And I believe there is a why, a deep, geometric, beautiful reason why the universe appears to have started in a low entropy state. And the answer is this: it did not. Let me explain what I mean. The problem with the standard story is that it treats time as having an absolute beginning. The Big Bang is time zero. Before it, nothing. No time, no space, no physics, just nothing. Or perhaps a quantum fluctuation, or a multiverse, or some other speculative mechanism we do not understand. But in any case, the Big Bang is treated as a true beginning, a boundary beyond which we cannot look. But what if it was not a beginning? What if it was a transition? This is the central idea of my conformal cyclic cosmology. CC, the Big Bang was not the start of time. It was the interface between one aeon and the next. The previous universe did not end in a singularity. It ended in something far stranger, an infinite expansion into a state of maximum entropy, a heat death, a cold, dark, empty universe where all the stars have burned out, all the black holes have evaporated, and nothing remains but a thin sea of massless particles drifting through infinite space. And here is where the magic happens. In that far future state, where everything is massless photons and gravitons, something remarkable occurs. The notion of scale disappears. Massless particles do not experience time. A photon traveling at the speed of light does not age. From its perspective, it is emitted and absorbed in the same instant, even if billions of years pass in our reference frame. And in a universe composed entirely of massless particles, there is no longer any meaningful way to define distance or duration. There are no atoms, no rulers, no clocks. The geometry of space-time becomes scale invariant, what we call conformal. And in a conformal geometry, infinite time is indistinguishable from zero time. This is not a trick. This is deep mathematical physics. When you perform a conformal rescaling, a transformation that changes the scale of space and time, but preserves angles and causal relationships, the infinite future of one aeon can be smoothly identified with a Big Bang of the next. The heat death of the old universe becomes the hot beginning of the new one, not through some collapse or bounce, but through a conformal transformation. The end becomes the beginning. High entropy becomes low entropy, but only when viewed from the wrong conformal perspective. From within the new aon, the Big Bang looks low entropy because we are measuring entropy using massive particles, using atoms and clocks, and structures that define scale. But in the previous aon, at the moment of transition, there was no scale. The state was actually maximum entropy for a scale-free conformal geometry. It only appears low entropy when we reintroduce scale in the new aeon. Entropy did not decrease. The second law was not violated. We simply changed the way we measure entropy across a conformal boundary. This is subtle. I know it is subtle. Let me give you an analogy. Imagine you are standing on a sphere, the Earth. You walk in a straight line, always moving forward, never turning. Eventually, you come back to where you started. Did you violate the law that says walking forward takes you away from your starting point? No. You simply moved on a curved surface where straight is different from what it seems. Similarly, time's arrow does not reverse in my cosmology. Entropy continues to increase within each aeon. But at the boundary between aeons, the geometry of space-time changes in such a way that high entropy in one aeon corresponds to low entropy in the next, not because entropy went down, but because the definition of entropy changed. Now, if this sounds like philosophical hand-waving, let me assure you it is not. This is testable physics. I have made specific predictions about what we should see in the cosmic microwave background. If this model is correct, and we have seen them in the 1960s, I proved along with Stephen Hawking that black holes must form in our universe, and in the previous aon, before our Big Bang, there would have been black holes too. Supermassive black holes, the largest structures that can exist, swirling in that ancient cosmos for trillions upon trillions of years. These black holes would have collided, spiraled into each other, released enormous bursts of gravitational radiation, and those gravitational waves would have left an imprint. When the conformal transition occurred, when the infinite future of the old aon became the Big Bang of our aon, those gravitational wave events would appear in our cosmic microwave background. Circular patterns, rings, concentric circles of slightly enhanced temperature fluctuation. Not random noise, but specific geometric signatures of collisions that happened in the previous universe. I call them Hawking points, in honor of my late friend and rival, and we have found them. My collaborators and I have analyzed the data from the Planck satellite, and the patterns are there, statistically significant, more numerous and more prominent than random fluctuations would predict. The universe is whispering to us that it is older than we thought, that the Big Bang was not the beginning, but a turning point in an infinite cycle. Some cosmologists dispute this. They say the patterns are coincidental, that we are seeing faces in the clouds. Perhaps science is never certain, but the mathematics is rigorous, the predictions are precise, and the observations align. I believe history will vindicate this model. But let us step back from the technical details and consider what this means philosophically. What does it mean if time's arrow does not have a single absolute direction? What does it mean if the beginning is also an end and the end is also a beginning? It means causality is not what you think it is. We are accustomed to thinking of cause and effect as a linear chain. A cause is B, which causes C, stretching back to some ultimate first cause, the Big Bang. But in a cyclic cosmology, there is no first cause. Every event is caused by something before it, infinitely back into the previous aeon and infinitely forward into the next. Causality forms a loop, a closed, time-like curve at the cosmic scale. This does not mean anything goes. The laws of physics are still obeyed within each aeon, but it does mean the universe is not contingent on some initial condition. It is self-sustaining, self-creating in a sense. The universe exists because it exists in a grand tautology that requires no external explanation. Some find this disturbing. The idea of an eternal cosmos with no beginning and no end is psychologically challenging. We like origins. We like creation stories. The Big Bang gave us that, a moment when everything began. CC takes it away. But I find it beautiful. An eternal cosmos is a cosmos that does not need a creator. It does not need fine-tuning or anthropic principles or multiverses. It simply is and has always been and will always be cycling through aeons in an endless dance of entropy and conformal transformation. And this brings me to the deepest question of all. What is the arrow of time really? Within an aeon, the arrow is clear. Entropy increases. The past is low entropy. The future is high entropy. We age. We remember. We experience time flowing from past to future because we are embedded in this entropic gradient. But at the cosmic boundary, the arrow loses its meaning. The infinite future of one aeon and the Big Bang of the next are conformally identical. To an observer in the far future of the old aeon, if such an observer could exist, the passage of time would slow to an infinite crawl. Billions of years would pass in an instant, and from their perspective, they would be approaching not an end, but a new beginning. The heat death would not feel like death. It would feel like rebirth. And here is the truly haunting part. If this is true, then we are not the first version of ourselves. There have been a before this one, infinitely many aeons, and in those aeons there were galaxies, stars, planets, perhaps even life, perhaps even people like us asking the same questions, discovering the same laws of physics. The information from those aeons is mostly lost. The conformal transition erases almost everything, but not quite everything. The Hawking points remain, and perhaps other subtle traces, other echoes of the deep past waiting to be discovered. You might ask, if the cycle repeats, does that mean everything repeats? Will I live this exact life again? Make the same choices, have the same thoughts? No, the cycle is not a perfect repeat. Each aeon has its own quantum fluctuations, its own initial conditions at small scales. The large-scale structure may be similar, but the details are different. You are unique to this aeon, this moment, this conversation, this thought you are having right now. It has never happened before, not exactly, and it will never happen again, not exactly, but something like it might in the next aeon, or the aeon after that, or a trillion aeons hence. Somewhere in the infinite chain of cosmic cycles, patterns recur not identically, but analogously. The universe explores all possibilities, not simultaneously as in many worlds, but sequentially across aeons. And that brings us to the ultimate cliffhanger. If the arrow of time is not fundamental, if it can reverse at cosmic boundaries, if the end of one universe is the beginning of the next, then what does that mean for you? When you die, when your brain ceases to function, when your neurons fire their last signal, when the entropy of your body increases to equilibrium, is that truly the end? Or is your existence, your pattern, your information encoded somehow in the geometry of space? I'm waiting to reemerge in some future aeon when the conditions are right. I am not talking about reincarnation or souls or afterlives in any mystical sense. I am talking about mathematical permanence. Every event that has ever occurred has left a mark on the structure of space-time. General relativity tells us this. And in a cyclic cosmos, that structure persists, transforms, carries forward into the next cycle. You are not separate from the universe. You are a pattern in the universe. And patterns, once established, have a strange kind of permanence, not in the objects themselves, but in the relationships, the geometry, the information encoded in the fabric of space-time. So when I say the arrow of time might be pointing backwards, I mean this: what you think of as the end, the heat death, the dissolution, the forgetting might actually be the beginning. Not of you, not of this aeon, but of something new, something that carries the faintest echo of what came before. Time does not flow from past to future in some absolute sense. It flows from low entropy to high entropy within a reference frame, within a conformal structure. But change the frame, cross the boundary, and the arrow transforms. The future becomes the past, the end becomes the beginning, and the cycle continues forever. So the next time you watch an egg shatter and think time only flows one way, remember that is only true inside this aeon. At the cosmic boundary, at the moment of infinite entropy, the arrow loses its meaning, and what comes next is not after, it is beyond after. It is a new dimension of causality. We do not have words for yet. The arrow of time is not backwards. It is cyclic, it is eternal, it is conformal, and you are part of that eternal pattern, surfing the wave of entropy from one A on to the next, never truly beginning, never truly ending, always transforming. And that is not the end of the story. It is the beginning of the next telling.